Welcome. This is worksheet number 10. We're going to deal with congruency, so lots of equations, lots of lines. So we have this parallelogram, and it says DEFG has coordinates D. So let's make this in green. So we'll do parallelogram DEFG, negative 6, 1, 2, 3, 4, 5, 6. 2 is going to be D. We have E, which is 0, 2. We have F, which is negative 5. 5, 1, 2, 3, 4, 5. That's F. And G is 1, 5. So that's G. Okay, and if we connect the dots, connect them with green, that looks like a parallelogram. Good. And now we have D prime, D, E. See, this is horrible. This is not correct. You would not name it D, E, F, G. You would not name it. You would name it D, F, G, E, D, E, G, F. So this is a bad, that's academic decathlon again. You just can't randomly pick points. It has to be clockwise or counterclockwise. Frustrating sometimes dealing with this. This is so contradictory of what. All right, now our new object is going to be negative 9, 7, 1, 2, 3, 4, 5, 6, 7. That is going to be D. E is negative 3, 7, negative 3, and at that same altitude. That is E prime, D prime. F prime is going to be negative 8, 10. So that's there. That is going to be F prime. And G prime is going to be negative 210. So that is G prime. And if we connect those dots, let's move that E over a little bit. Oh. Well, let's erase that and we can redo our dot. Good. So the question is, are D, E, F, G and D prime, E prime, F prime, G prime congruent? They are congruent. They're going to have the same length. They're going to have the same height. They're going to be same slopes also. So this slope is up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. And so those are congruent objects, yes. Same location, D, D prime, F, F prime, G, G prime, E, E prime. Same location, same, even though it's incorrect to its listing, it's still the same. So let's move you a little bit too. That's both of my E's were a little bit off. Let's go green and make the dot there. Good. All right. Next one says, what is the equation for the line connecting D to D prime? Okay, so we talked about slope. So let's look at those 2 points again. Let's take D. D is negative 6, 2, negative 6, 1, 2, 3, 4, 5, 6. Whoops, sorry, 2. 1, 2, 3, 4, 5, 6, 2 would be here. That is going to be D. And then D prime is negative 9, 7. So 2, 3, 4, 5, 6, 7. That would be D prime. What is the equation of the line connecting these two? So if we had a line, let's pretend we had a line there. Let's go dotted. Boop, 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 boop. So we have a line that looks like that. We can find the slope. Remember, line, we can write in linear equation, one of the easiest linear equations. Well, actually, Would that be the easiest? We'll make it. We'll show it with it in slope-intercept form. They should have said, what is the equation in whatever slope-intercept form? So the slope is rise over run, 1, 2, 3, 4, 5, up 5, 1, 2, 3, left 3. So my slope equals up 5, left 3, which gives me negative 5/3. So I have y equals negative 5/3 x plus b. Now I can continue to extend this. I could take this and extend it out, and I could take an estimate about what I think it is, maybe negative 8. Or I can take a point and I can plug it in, because I know one of the points, I know that d prime is negative 9, 7, and I know that d is negative 6, 2, and I can plug it in for the x and y and solve for b. I would have b by itself. So let's take this one. Let's take d. So my y value is 2 equals negative 5/3, and then I get negative 6 for my x value plus b. So it is 2 equals, these are going to cancel. That's going to be 2, so negative 2. So that makes positive 10 plus b. Now we'll subtract the 10 from both sides, and we get negative 8 equals b. And that's what we had assumed. We had said that it might be. So the equation for the line that connects those points are y equals negative 5/3 x minus 8. That is the dotted line. That's the equation for that line. What is the equation of the line connecting E to E prime? Well, we can make some assumptions about what we think. I kind of think it's going to be the same slope, or the same equation. Different equation, sorry. Same slope, different equation. So that's E, and E prime is going to be negative 3, 7. Let's connect that dot. And we know what the y-intercept is here this time, which is very efficient. So we can calculate the slope. Slope equals 1, 2, 3, 4, 5, left 1, 2, 3, so negative 5/3 again. This time my y-intercept, I can see what it is, because the point 0, 2, so my y-intercept is 2. So my equation is going to be y equals negative 5/3 x plus 2. So same slope, different y-intercept. What is the equation for f? We know again, I know my slope's going to be the same, and then my y-intercept's going to be different. So let's do f is going to be negative 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That is f. F prime is negative 8, 10, which is here, f prime. And if we connect the dots and extend it down, yeah, we can make an assumption that that's going to be about there. Yeah, that looks good. So my slope, I'm going to make an assumption it's negative 5/3. 1, 2, 3, 4, 5, 1, 2, 3. Yep. And my y-intercept, so I don't have it. I can do the thing again. I'm going to pick a point. Let's take the green f value. So we get y equals negative 5/3 x plus b. My y value is 5. My x value is negative 5 plus b. Ooh, so that actually looks a little ugly. That is not going to be clean, I guess. So we get 5 equals 25/8 plus b minus 25/8 minus 25/8. 5 equals how many in eighths? 40 eighths. And that gives us 15 eighths equals B, which is a little bit under 2. What? Whoa, okay, that's wrong. So what did I do wrong here? F negative 8. Oh, no. F is negative 5. 5. Negative 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 8, 10. That's correct. My slope is negative 5/3. That makes positive 25 eighths. That's 15 eighths. That's correct. Negative and negative. X, that going in X, that's my Y. Why is my graph off so much? I mean, okay, I extended it. So that's, I mean, did I extend it that far off? Whoops. So is it really here? That looks pretty, that looks way off. Yeah, that looks more. 8 and 8, 16, 8, right? Well, I did it. 5, that's 25. 25 eighths, that's correct. 5/3, not eighths. Ding dong. That's what happens when you write messily. That is what happens when you write messy. That's 1/3, silly. 3. 25 thirds, thirds, thirds. And thirds would be 15. Hello. 15 thirds. And that gives us negative 10 thirds, which equals B. That's a little bit better. That is negative 3 1/3. So yeah, I get that. That could definitely be right there. So negative 3 1/3 is a much better number for my y-intercept. So my equation is y equals negative 5/3 x minus 10/3, and that is much better. Okay, what do you notice about the lines you found in numbers? They have the same slope. Slope, negative 5/3, but different y-intercepts. Good. And can you make a prediction about the characteristic of the line connecting? Same slope. It has a slope of negative 5/3. And parallelogram has undergone some changes. Was produced that, so has undergone transformation to produce. Are the two figures congruent? So parallelogram, oh, whoops. No, this is not, that's not from this. Delete. Let's move that up. Good. All right, different question. So let's do G is 2, negative 1. H is negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. And negative 1, 5. That's a real ugly, ugly triangle. Okay. Academic decathlon, you're again not helping yourself. Okay, but we graphed it. And let's do blue, which is G prime, which is 4, 2. 1, 2, 3, 4, 2. Negative 6. 1, 2, 3, 4, 5, 6, 9. And negative 2, 8. Again, not the greatest of lines. But let's take a look at this object. And what do we know about it? Let's fix that line a little bit, fix that line a little bit. What do we know about it? Well, to me, they are not similar. Are the two figures congruent? They are not congruent, but they are similar. And similar, well, then no, they are not congruent. No, not congruent. Not congruent because they are not the same lengths, and they actually don't even have, they're not even similar. It's not like this has been rotated a little bit. Maybe rotated a little bit and extended. So it's clearly been dilated. So blue is bigger than green. We know that. So that's it, huh? No, one of the coordinates has been multiplied, so the figure is larger than the other. Good. Same slope. Good. They have the same slope. All right. Oh, they went in point slope form. Point slope form. All right. Well, it didn't tell us what form that they wanted in, so that's fine also. We could have done that in point slope form. Pick a point, plug it in to y minus y sub 1 equals m times the quantity x minus x sub 1. Good luck.